we started with the Academy a couple of months ago, and we already have 7 courses that are online. And for 5 out of these 7, you can see them with the green check mark. We have already organized the online sessions. The online sessions that we have organized, as I said previously, you can find them, you can watch the recordings, in addition to the online material that was anyway available through the Academy website. You can find them all collected in one place, and you can check again what has been presented and discussed. In the coming months, we will now make a short break, also because of the summer. And in the 1st of September, we organize a session that is a follow-up session on course 4, which is an Ask Me Anything session in relation to the minimum requirements for submitting a project charter. This is addressed mainly to the people, to the grantees that need to prepare a project charter. They will be working on the project charters in the days before and in the period before. The submission is a couple of days after this online session. So the idea is that we come together and we discuss, we collect any questions or concerns or issues you may have. It is an open session. No standard presentations, and we discuss about the project charters. After this, we will continue with additional online sessions within 2026. And of course, after the summer break, we will also have further updates on the Academy website. Today, we discuss about the AAI, EOSC AAI. It is something that was very clear to us also during the discussions we had in the winter school, that it is a very important topic for the community. And here you can see some screenshots of the content, the course description that is available on the Academy website. People who have contributed to this is Mario, Andy, Christos, Irina, and Peter. Who have contributed with the current content, which will be, as I said, also further enriched in the coming months. And today we are very happy to have with us Mario, Christos, and Irina. And this is the agenda for today. We will have first the introduction to course 7, and then an introduction to the EOSC AI and some practical and operational guidelines for the notes. And we will close with a Q&A session that Isabel will be running. Irina is an information technology delivery manager at Jean. Christos is a senior trust and identity manager at Jean as well. And of course, co-chairing the AAI Architecture Task Force. And last but not least, Mario was with Jean, but now is serving as the technical coordinator for the EOSC Federation. And with this, I will give the floor, I will stop sharing and give the floor to Irina, Christos, and Mario to start with their presentation.
So, good morning, everyone. This is the course on the EOSC AI Explained. This is the first module of an envisioned series of courses around the AI. But today we're going to be focusing on bringing everybody up to speed. Next slide, Mario, please. As already mentioned by Eleni, there are 3 parts in this webinar. The first part is an introduction of what we're going to talk about today. Then we're going to cover an introduction of what the EOSC AI is, and then some practical and operational guidelines focusing on EOSC nodes. Next slide, please. And next slide. Okay. So what we want to describe today, we want to give you information about what are the goals for the EOSC AI, what we want to achieve, what is the underlying architecture, what use cases we are aiming to support with the EOSC AI at this point in time, and what are the guidelines for implementing the EOSC AI on existing and upcoming nodes. The focus of this presentation is AI managers and staff that are implementing right now AIs for upcoming EOSC nodes that are going to join the EOSC Federation. So we will be having in the future also other courses focusing on, for example, service providers, etc., and how they should understand the EOSC AI and how they can benefit from the EOSC AI for their own services. But today we're focusing mainly on those people who are responsible for delivering the AI for the respective nodes. So this course today, so Martin, thank you.
Oh,
Christos, you're muted. Christos?
Okay, so somehow I was muted and unmuted. Can you hear me now? Or you didn't hear anything? What happened?
We didn't hear the last seconds, but yeah.
Somebody muted me.
Okay.
It was a message or something, in any case.
apologies, that was my mistake. Apologies.
So I was saying that today we want to go, or I don't know if what you heard or not heard, but the course today is going to give you the overview of the supported use cases for the EOSC AI and the AI Federation, what it is, architecture insights. Perhaps you have already heard about the hub and spoke model in the current EOSC AI Federation with Mike's supporting these functions, and the integration guidelines, the practical steps for each node to connect to the EOSC AI. Our goal right now is to move existing nodes, those nodes that are so-called from the wave one to the production infrastructure of the EOS Federation, and also to help the new nodes, those nodes that are part of wave two, to onboard themselves on the EOS AI. Can you go to the next slide, please? So in order to understand the EOSC AI, of course, you will get here an overview of what it is, some high-level information. But in order to really understand how things are working and what are the requirements, you need to get yourself familiar with the various documents that have been put in place to support the EOSC Federation. The first and foremost is the EOSC Federation Handbook. You get a general overview of what is required to be part of the EOSC Federation. Then, specifically for the EOSC AI, last year we published the EOSC AI architecture document. This architecture document gives all the information that EOSC node operators need to have for the AI aspects on what is required in terms of technical requirements and policy requirements for a node to connect to the EOSC AI. The EOSC architecture is not something that we came up out of the blue. It is based on the ARC blueprint architecture, so familiarity with that is also important. And in the document, you will also see there that there are a number of references to other specifications, like, for example, the ARC blueprint architecture itself that describes the overall general concept of that we're implementing within EOSC. The guidelines for expressing affiliation information from ARC, another document that we're using, another specification we're using within the EOSC AI, guidelines for how to express group membership, project membership, and role information across nodes, how to do auth2 proxy token introspection, and a specification for IDP hinting. Now, I can understand that right now all this might sound perhaps too much, but throughout this presentation, we're going to give you an introduction to all of these concepts, and then you can also read the documents, understand them, and if there are questions, here we are, we can reach out to us to discuss them. The EOSC working group meets every second Friday, and this is the place to have discussions with all the EOSC nodes. And with this, let's go to the next slide, which is really about the EOSC working group. The EOSC working group is the place where we expect to have all the people responsible for implementing the AAIs across the EOSC nodes. Our mission is to drive the operation of the production federated AI in EOSC and to provide a central point for all activities related to the AI within the EOSC ecosystem. The participation in the EOSC working group is basically the representatives of the EOSC nodes. But in addition to that, we have made sure that we have in the EOSC working group the number of experts across Europe and beyond that can help us ensure that what we deliver for the EOS and the AI makes sense also on the international stage and it can support science at large. So within the EOSC group, we define the operational roadmap for the EOS Federated AI. We set the priorities, we define the policies. As I mentioned, we meet every 2 weeks. And if you want to have more information about what we're doing, you can find the rules of procedure that is published and it will be available in the slides that you will get after this meeting. So with this, I don't want to bother you with introductory more. I would like to pass now the floor to Mario, who is going to walk you through all this information and give you an overview of what I mentioned already. Thank you very much. And Mario, I hand this over to you.
Thanks, Christos. So good morning, everybody. So I'll now dig a bit into the EOSK components and so to provide the central part of this training this morning. We thought about reminding you about what the EOSC wants to achieve, what the EOSC wants to do. So what the EOSC user will be able to do through what we are implementing. So the users will be able to access computing services, run scientific workflows within their nodes, but also across nodes, data service, so utilize advanced data storage and data management service, virtual research environment that's suited for their needs, browse and access research data sets in a fair approach or machine actionable research data sets and discover resources online, basically, by browsing catalogs. And all this basically happens through the AI. So in a single sign-on approach, that's what we want to deliver. And that's why, the EOSC AI is federating capability number 1 in the EOSC handbook, as you are aware of. So all this basically is enabled through the EOSC AI Federation, which is the operational framework behind all this that is implemented through the AI infrastructure. So before we start, just to make sure we use the right terms in the right context here, just to be clear about that. So this is again from the EOSC AI paper 2025. So when we speak about the EOSC AI, we refer to a federated identity and access management framework that enables research and service provider to authenticate and authorize user in a secure and interoperable way. Basically, the EOSC AI, as such, provides a technical foundation for the federation and enables single sign-on across services. The EOSC AI Federation is the operational framework that ensures AI interoperability across EOSC nodes. Basically integrates multiple identity federation to create a trusted federated ecosystem. And so implements the framework at a broader level and provides identity services to EOSC nodes. The EOSC Federation, as such, as you know, is the overall federated structure of interconnected services, resources, and infrastructure across Europe under a common governance model, which is composed by the nodes and coordinated by the EOSC Association. And an EOSC node is a regional, national, or thematic infrastructure that provides resources, services, and data. So let's use the right terms in the right context to agree on those when we talk to each other. And for what matters for us, each node follows EOSC policies for interoperability, represents specific service provider, it's an integration point for services, but for what relates to this webinar, operates under shared AI policies. This is the important bit here. You probably have seen this picture. It's the concept, the whole concept of the EOSC, right? And what we wanted to summarize here is why the AI plays this fundamental role, the EOSC AI, in delivering what EOSC aims to deliver. So for researcher, the EOSC AI provides secure access to your services and resources via their own home organization identity provider and grants them the ability to do it through a single sign-on single sign-on process, let's say. For service providers, this is a consistent way to authenticate user and authorize their access based on open standards and reference architecture that ensures interoperability. So this is a familiar picture where EOSC basically you see that users data and services are build up the EOS through nodes. So a couple of slides on what Christos already mentioned is a milestone in this domain. The work that was done by the ARC project, by Christos and his team back in 2017, 19, some years ago. This was started, and it's basically there to ensure this what we refer to the ARC BPA, so the blueprint architecture, is there to ensure interoperability for AI infrastructure. So as such, the blueprint architecture is a reference template model identifying all relevant AI functional layers and the elements that build the AI as such, and it provides a model for interoperable AI solutions in the research and education domain. This document was updated in 2025, and basically 5 layers, 5 components layers have been identified. The authentication layer, which is the upper part that you see in this picture, the attribute service to the left, the access protocol translation, which is at the core of the BPA, the authorization to the right, and the services at the bottom layer. So it's a model. The reason why this is important is that this is the language that the AI people talk when they discuss with you how to integrate your node, how to integrate your proxy, and what are your requirements. Basically, it's a model that really works well, and we understood that describe AI in general in this domain. So as I mentioned, you see that the red arrow flows here are the unauthenticated user. The top layer, the purple one, is the identity layer, where basically several sources of identities are interfaced to the AI, and you see that I would say the bulk of it probably comes from the National Identity Federations and EduGain, which is a federation of federations, basically. And you see that community AIs as well, they play a role in this layer of authentication. The core of it is the access protocol translation. If needed, the proxy is there also to translate protocols, for example, from SAM2 to OpenID Connect. And it's the core of the whole architecture. And then attribute servers are to the left of it, and you see attribute authorities there. The authorization bit is to the right, as I mentioned, but authorization crosses also with the service layer, and services are basically the ones that here deliver integrated to the proxy. As I was mentioning in the 2025 version of this document, the concept of functional capability has been introduced that basically represent a cohesive set of functions that collectively support a specific aspects. And so 3 main functional capability view have been identified, and they provide modular implementation, clearer governance, improved alignment with community infrastructure needs. So it's a convenient way to represent the blueprint architecture. So as I mentioned, identity management, collaboration management, and service integration are these functional views, functional capability views. And to the identity management part, you see that belongs authentication sources, user identifier, identity linking, quality of authentication, quality of the identity. They all belong to the identity management capability view. Then the collaboration management spans basically membership, groups and projects, rights and roles, and service integration that deals with infrastructure services, infrastructure policies, resource capabilities, and then federated local user mapping. As you see, service integration, each one of them spans multiple of the components that you've seen before. You see that basically also represented in the schemas. So coming to the EOSC itself, what are the main benefits of the AI? Well, the key benefits that are provided to the EOSC are federated authentication, as I mentioned, single sign-on across node and cross-node collaboration, which is which is a broader concept, if you want, because doesn't necessarily imply web access, and persistent identity. That is a layer that is also provided by the EOSC AI. As you can see, we will probably have already mentioned. So in the view that we currently have, there are EOS nodes, and each node provides at least an infrastructure proxy. That is what you have to provide basically to join the EOS Federation, which is the aggregation point for your services. And then nodes can have their own community AIs that might be integrated to the rest of the whole AAI implementing these services for you and for the federation. So the infrastructure proxy is the minimal requirement for you guys to provide with your node as an integration point to your for your services. Also, My Access ID is a service provided by Géant, is at the center of this architecture. It's a hub and spoke architecture and plays this fundamental role of the identity layer that implemented within the EOSC AI. So nodes, the nodes proxies are interfaced to the My Access ID central hub. And as you know, nodes can be regional, thematic, or national nodes. And My Access ID provides a central component for the AI, providing, implementing this hub and spoke model, providing IDP discovery, token validation across nodes. We will see that. And the basic reference protocol here is OpenID Connect or through. Again, few slides on My Access ID. What is the role of My Access ID in the EOSC AI Federation? Well, of course, it provides trust. It's the ultimate source of trust here. It's at the center of the trust model. So the identity provided establish a trust relationship with it. And the same applies to the community AI and the infrastructure proxy. Basically, as I mentioned, it's a hub and spoke architecture. But de facto, My Access ID enables the implementation of the EOSC AI Federation. So as I mentioned, the EOSC AI is a federation of AI infrastructures, sharing trust across the whole ecosystem. They share trust via the functional components of the EOSC, and the relevant protocols are OpenID Connect out and some too, if you want to describe the key components of it. Again, My Access ID, several features. It acts, in fact, as the identity layer for the EOSC AI, and basically it grants basically the interfaces, user identities across the whole EOS set of nodes, and it is the central gateway for authentication. And several authentication domains are plugged to My Access ID. So again, I would say, again, probably the bulk of the identities are in research and education coming from there. So it's an interfederation. It's a federation of national identity federations. The reference protocol is SAMP2. But then you see that also IDAS is the governative identities for EU citizens. And community platforms and the EU login through the European EU node. The other trusted sources are plugged to My Access ID as sources for identity. And of course, it directly accesses nodes infrastructure proxy, the My Access ID, and access community AIs for authentication infrastructure proxy when appropriate, when needed. Again, the aspects that enable web single sign-on across no collaboration for My Access ID here at the center also is identity layer capabilities. Basically, My Access ID provided an access registry. It acts as the fundamental central IDPSP proxy. Identity provider discovery, which is a key component of the whole process, metadata and trust anchors aggregation, persistent identifiers, and a token validation service. So you see how multi-faceted is MyAccessID in his central role in the EOSC AI. So now bear with me about these 4 slides. We'll go, I think once in a lifetime is worth seeing this. We thought that it would be useful also for you to understand once, to see at least once what the flows are for the 2 main supported use cases. Again, this is all something you can read in the EOSC AI paper 2025 version. But we thought it would be useful today to go through the steps together with you. So I have 4 slides about that. The first 2 refer to the single sign-on use case. You see a user, step 1 in the bottom left, that wants to access service 1. You have node X and node Y, node X to the left and node Y to the right, and MyAccessID, the hub at the center. The identity providers are in the upper layers, you remember from the BPI architecture time. So user wants to access service 1 on node X, and since it is unauthenticated, service 1 redirects user to node X infrastructure proxy. And the infrastructure proxy redirects the user to the central MyAccessID proxy. That's the way it is. So at step 2, the user is now landing on the MyAccessID central proxy. A user here selects the identity provider he belongs to through the discovery service. And at step 3, here you see that the user is basically redirected to his own IDP for login and provide consent. Basically, in the usual way, he is used to use the services in EduGame, for example. So he selects his idea. Once he selected his identity provider, he logs in, providing his credentials. And at step 4, the IDP relies user identity information and the attributes back to the MyAccessID layer, the central component. So which receives a valid token for the user. Then MyAccessID provides user information back to the EOSC node at step 5 here, to the EOSC node X infrastructural proxy. Since it's a proxy in itself, the proxy might further enrich the user information before forwarding it back to service 1. So service 1 then authorizes the user, the authenticated user, with the proper attributes to make use of these services. Now, the second slide about these use cases. Now, let's see what happens when the user now wants to access, service 4 on node Y. So now is changing the reference node for the service. So again, at step 7, a user wants to access service 4, and service 4 at step 8 redirects the unauthenticated user to the infrastructure proxy of node Y. So the user is here. At step 9, the infrastructure proxy for node Y recognizes that the user must be authenticated via MyAccessID. So it basically let the user land here at the MyAccessID. Now, since the user has a valid single sign-on session, MyAccessID quickly redirects the user to the same identity provider. So at step 10 here, at step 11, the IDP confirms that the user has a valid single sign-on session, giving the existing user session with a home IDP. So there is no need for re-authenticate the user. And in practice, this what happens is basically at step 11 is that the MyAccessID now as a recognized this is an authenticated user. So at step 12, MyAccessID returns back user information to the node Y infrastructure proxy, and as before, the infrastructure proxy might want to enrich further the user attributes if needed. At step 13, the infrastructure proxy that you see here at node Y basically send the user back to service 4. Fully aware of the user identity, service 4 allows the user to consume its services without requiring another full login. So this, 13 steps are what happens every time behind the scenes when the EOSC AAI is in action and the user experience web single sign-on. A similar situation, but in a broader context, is basically what we call the cross-node workflow, which is the second also the second important use case supported by the EOSC AAI. So now we have a user that basically again wants to access service 1 on node X. And the workflow that I described before applies basically to the left side. So node X infrastructure proxy sends the user to my access ID at step 2. Upon arrival on my access ID, again, there's a discovery service. The user gets redirected to the identity provider. And once the user is authenticated by providing his credential or her credential, so the information about the user is sent back to the my access ID at step 4, which now owns valid user information. At step 5, my access ID confirms user identity and sends them back to the NodeX infrastructure proxy. And once verified the user identity, now NodeX issues to service 1 a valid token that we call ATX for the user. So basically, and then of course, the user can access service 1. But now we add that NodeX has issued an access token to the user that is there. Now let's see what happens by means of this access token if a user now wants to suppose access service 4 on node Y by willing to access, for example, a service through the APIs that are exposed by service 4 on node Y. So this is just more general than only web, basically. So now a user wants to access service 4 on node Y, what service 4 is configured to perform token introspection and calls the introspection endpoint of its local node at the infrastructure proxy. The infrastructure proxy of node Y recognizes that it did not issue that token, so the token was not issued by me, says node Y's proxy. And then, but of course, it makes use of my access ID, and then again, the key role of my access ID in this whole game as a common source of trust, and uses the proxy token introspection feature. So basically, at point 10, my access ID recognizes that the ATX token, point 10 is this one that goes from my access ID back to node X. Recognize that the token was issued by the infrastructure proxy of node X, and it calls the introspection endpoint of node X. This way checks the active state of the token that was issued by node X, and grants and checks the validity, basically, of this token through node X infra proxy introspection endpoint. At step 11 that you see here, node X introspection point returns my access ID confirmation on the validity of the token that has been issued by it after having introspected it along with the user identity attributes. So my access ID at step 12 that you see here to the right provides user valid verified token to access node Y infrastructure proxy services and send valid user token to the infrastructure proxy of node Y. Then the final step is that the node Y infra proxy authorizes the user after having verified the validity of the token tied to an authenticated user. It informs service 4, which then authorizes the user request. So the bottom line of this whole cycle is that with the token successfully validated, the user can consume service 4 APIs within EOS node Y. So again, we see what the workflow is in terms of steps for this what we call the cross-node workflow use case. Now I will go through to the steps that are required, basically to the various features that are provided by the EOSC AI, and I made use of what is provided by Christos thing, the Excel file that you will be getting familiar with, where everything is tracked around the progress. So basically, I thought about wrapping up a bit the summary of the following slides in a single slide here, which you might take it as an initial wrap up of what will follow, if you want. Initial summary, what I will then explain in more detail through the next slides. So this initial overview slide summarizes a bit what is needed. In terms of protocol and connection to my Access ID, you do provide your infrastructure proxy. You connect it to my Access ID as an OpenID Connect relying party, and you need to provide support to the OpenID Connect discovery, and then you need support the Pixie extension for the authorization code flow. That's another important feature that has to be provided in order to integrate with the EOSC AI. In terms of token management, you need to provide an OAuth2 token introspection endpoint to your proxy. You need to support an extension of this protocol that was defined by the ARC project that is called proxy token introspection. And then you need to support EOSC AI claims and scopes, of course, because that's the context where we are operating. In terms of groups and roles, you need to provide support for processing of groups and roles according to the guidelines that are provided by the ARC G69 document, which is essential for fine-grained authorization across nodes. In terms of security baseline, you need to be compliant with the referred and incident response. You need to be compliant with the referred incident response, the certified referred incident response framework. So this is just a bit of a summary of what I'm going to show step by step in the next slides. And you see that this banner that describes the various aspects of this Excel file that is used by the team to track the progress of your integration into the EOSC AI. So as I mentioned, the first relevant feature is to provide a node infrastructural proxy, and it's fundamental that every node must provide at least its infrastructure proxy. This is the single point of access and integration for all the services, and you need to provide support for OpenID Connect to out as a primary protocol and SAM2 as the reference protocols for this AI. In terms of the integration of the community AI, some nodes, not all of them, but some nodes might have their own community AI. So nodes can actually deploy their own community AI for local user authentication that interfaces to multiple authentication sources and acts as an authoritative source of identity for the global KSQI. You remember that in the BPI schema, community AI are also part of the identity layer in this respect. Then what you need to do through your proxy is you need to support the OpenID Connect discovery protocol as a client, as an OpenID Connect client, and as an OpenID Connect provider. So every infrastructure proxy must support, as I mentioned already, OpenID Connect to out as an underlying protocol, and the proxy must provide support for the OpenID Connect discovery protocol, both as a client and as a provider. And you need to publish, the proxy needs to publish its own configuration metadata at a well-known endpoint to enable automatic discovery for the string clients. And basically, this endpoint responds to the HTTP GET request with a JSON file providing the proxy OpenID configuration metadata. That's at the key of you've seen it in the workflow that I showed before for the use cases. Discovery is fundamental. Is functional to the implementation of the EOSC AI. Then you need to support the authorization code flow code flow, which is one of the support flows in OpenID Connect. And again, this is done by your proxy. Your proxy needs to support that as an OpenID Connect client, and also as an OpenID Connect provider. What does it mean in practice when the proxy is acting as an OpenID Connect client? What it matters, what it implies in practice is that the proxy provides, this implementation steps, initiate an authentication request. So when a user needs to authenticate, redirect them to the upstream OpenID provider authorization endpoint with the proper parameters, receive authorization code, of course, so accept the HTTP redirects from the upstream provider, containing the authorization code and the proxy register redirect URI, exchange codes for tokens, so make a server-to-server POST request to the upstream provider endpoint, presenting the authorization code, kind credential, and the redirect URI to obtain the tokens and the access tokens and hopefully refresh tokens. So the ID, the access, and the refresh tokens, and validate the ID tokens in practice. So verify the signature, the issuer, audience expiration, and retrieve user information when needed. So this is what happens functionally when you implement authorization code flow as an OpenID Connect client through your proxy. The proxy must maintain proper OpenID client configuration. So basically, it needs to store and use client ID, a client secret for confidential clients, the so-called client credentials when exchanging authorization codes, redirecting the URI register, it's callback endpoint, basically through the redirect URI registration with the upstream provider and ensure that it matches exactly in all requests. Maintain state and unknowns values across the redirect flows to prevent CSRF and reply attacks, and securely store the received tokens. So for the duration of the user session. This is just to give an idea what happens behind the scene again when your proxy is acting as an OpenID Connect client. In terms of in practice, for what is concerning the proxy flow integration, the node infrastructure proxy orchestrates two separate OpenID Connect flows simultaneously. The proxy effectively decouples the downstream client from knowing about the upstream provider existence. So it manages two independent flows in this respect. And in terms of operational flow, when a client initiates out, the proxy acts as an IDP. The proxy can delegate, transparently initiate its own authorization code flow with the upstream provider when it acts as a client, and finally translate results into token session for the downstream client. So that's really what happens in a proxy that is in the middle of the flows. When your proxy acts as an OpenID Connect provider, again, within the authorization code flow, the proxy must implement and expose core endpoints for the downstream clients, the so-called relying parties, during the authorization code flow. So it serves an identity authority for those clients, and it has to of course, implement the mandatory token endpoints. So basically, the proxy must provide the mechanism for client to exchange authorization codes for security tokens, and through the token endpoint, basically, it accepts POS from authenticated clients, validate the client authentication, verifies the authorization code is valid, issue cryptographically signed ID tokens in the JWT format that contain the user claim, the identity claims, issues access token for accessing protected resources, and in case of need, issues refresh tokens. So now coming to another feature of the AI, which is the PXE support. When when the proxy is acting as an OpenID Connect client and support the PXE extension, What it does in practice generates and manages the PXE parameter during its authentication code flow interactions with the upstream OpenID provider. What it does, it adds a cryptographic challenge response mechanism to protect against authorization code interception attacks. So it's a mechanism that was added to enhance security in the authorization code flow. So basically, in the initial authorization request, it generates a code verifier, compute a code challenge, store the code verifier, and include the PXE parameters. This is what happens in practice. And as a provider, so as we mentioned, it must accept, validate, and enforce PXE parameter as a part of the authorization code flow. And supporting PXE prevents authorization code injections, interception attacks, particularly for public clients that cannot keep a client secret. And that in practice provides defense in depth, even for confidential clients, basically. This is really a best practice and might have been made mandatory now, but it's really what needs to be done with the authorization code flow to add PXE extension. I'm almost done in this excursus through the different features. So what you've seen in the workflow that I described, that you need to support an extension of the token introspection, which is called the proxy token introspection. That is a mechanism that was designed and conceived within the ARC project. And it's there to, you've seen the cross-node collaboration workflow. That is a fundamental part of the process. So it extends the R2 token introspection method, which is defined in RFC 7662. It basically, as you've seen in the workflow, it defines a method for an authorization service that receives an introspection request for a token that it did not issue. So you realize that the proxy received an introspection request, but the token was not issued by the proxy itself. So and through this mechanism, the proxy can query different trusted authorization servers. And this enables the authorization server to determine the activity state of the token and retrieve the associated metadata. Again, we have seen this into the steps that we described for the workflow of the cross-node collaboration. Another important aspect is the IDP hinting needs to be supported. Again, according to another relevant ARC guidelines set is a G61. So your node proxy must support the IDP hinting according to these guidelines provided by the ARC project. It's a required functionality for the EOSC AI. This G61 defines a generic rules-based protocol-agnostic mechanism that we call IDP hinting for telling services and SP IDP proxies which upstream proxy or authenticating IDP to use. So it's a smart way to handle, and it's part of the discovery process. So basically, if you want, it simplifies the discovery. This lets entities bypass or simplify the discovery and route the user directly to the right identity provider. And it is, protocol agnostic in the sense that it works in the way it was defined, both for SAM and OpenID Connect. It introduces some key definitions. You will understand and frame them better by reading the document. But basically, it has introduced key concepts like hint producer, hint consumer, entity identifier, authenticating IDP. These are some of the elements that are part of this recommendation that needs to be supported. Then you need to express groups and role according to the guidelines provided by the ARC-G 69 documents. So basically, community namespace is fundamental to be provided because basically gives each community a protocol-friendly unique identifier. It allows consistent interpretation, allowing to define roles and groups and entitlement in standard ways. that every EOSC node can interpret consistently. So it's an important element of the cross-node workflows where you need to manage authorization in a proper way. And so basically, there's a document that describes that. As I mentioned, there's this ArcG69 document that basically, in terms of federated infrastructure, what it does, it prescribes how to express group membership and role information in federated research and education identity infrastructure. In terms of namespace, define the common namespace for exchanging group and role information across EOS nodes. And in terms of practical recommendation, covers attribute format, release policies, authoritative sources, and interoperable mapping between providers and services. The final bit of these discourses is about the URN namespace management. So Nodes with Community AI should provide the URN namespace to enable cross-node management of groups and roles. If you do not already have one, you can register your URN namespace within Geant. And I think this is my final slide. No, there's another slide about services, but what is important again, but I will leave this to Irina. Basically, what are the necessary steps for registration that you will see. So as I already mentioned, the certified compliance, the AUP, the privacy notice, and being a legal entity. Irina will go into this into more detail. Now, how do service join the EOSC-AI Federation? This is just a
meeting is being recorded.
A reminder about the fact that services are onboarded to EOS nodes. That's the way a service joins the federation. So it does not directly connect to the EOSC-AI. It goes through the node. So as I underlined in the slides, we underlined in the slides before, the EOSC node in practice is the integration hub for the node infrastructure proxy act as an integration point for the node services. In terms also the nodes handle the enforcement and compliance to policies and access policies. And then my access ID authenticates user via EOS node infrastructure proxy, as you've seen in the workflow I described. The key takeaway, and I think this is my final slide, and it's that services are onboarded to local nodes, which then interface with the global EOSC-AI Federation. So this abstraction ensures seamless integration in unified access management. I think this was my last slide. I think we'll addressing comments and questions at the end of the session.
Okay, so Mario, Christos and Mario, thank you very much for your presentations. Usually we have the Q&A at the end of the presentations. However, we have a very specific question from Zacharias in the chat. So I would like to ask you, Mario and Christos, if you would like to take some minutes just to reply directly now, or if you want to reply at the end of the presentation from Irina's presentation.
If you want, I can. I was already typing an answer in the chat, but I can share this now, perhaps very quickly, and we can have a discussion also afterwards at the end. So very briefly, just to touch on this point, this is a point that actually we deliberated quite a lot in the EOSC working group, and I believe also the rationale is explained in the EOSC architecture document. Imagine right now, today, we have 14 EOSC nodes that are connecting the federation. 14. We expect the next month this number to increase to 28, another 14 nodes. Imagine now, and we expect something very modest, 10 services per node. The actual expectation is 100 services per node, but let's say 10 for the sake of the discussion. That would be across the whole federation, 300 services across like something 28 nodes. So if we didn't have now this central component, effectively, every node would have to onboard hundreds, if not thousands, of services to their OPs. And every time we add a new node in the infrastructure, this whole thing increases exponentially. So this was an issue that we saw immediately. And clearly, this could not even scale to where we are right now, not to where we envision the EOSC Federation to go towards, right? So this is why we introduced this central component. And what we describe in the EOSC architecture also is a vision for a path forward. We do believe that technologies like the OpenID Connect Federation protocol would allow us to be able to scale without having a central component. But it is too soon right now to implement this. It doesn't have the maturity yet. There are still many other capabilities that are that will be missing with OpenID Connect Federation. So in order for us to be practical and say, how do we achieve and deliver this right now? The only solution was really, and this was the result of the EOSC working group, to go down this path and in parallel invest on how we can get OpenID Federation down the road when it matures more. We're already working right now to set up a piloting environment for OpenID Connect Federation. This is something that will come in autumn, but we don't expect this to be operational anytime within the next year. There's quite a lot of work is required towards this direction. So we had to level between what do we do right now and how we want the EOSC AI Federation to look like. And this is what we describe in the EOSC architecture document, where we try to describe what do we do today, but at the end of the document, you will see also a vision of where we want to get to. We can discuss more at the end of the presentation. Don't want to take more time from Irina right now, but I hope it is clear why we're doing this right now and happy to discuss more later.
Thank you very much. So Irina, the floor is yours now.
Okay, thank you so much. So I was already introduced, but just a few more words about myself and about my work. I work at Giant as an IT delivery manager in the trust and identity team. And our team develops and supports Core AI platform, which is a technological backbone for a range of AAI services supporting research and education in Europe. And one of these services is my XSID that we are talking today about, which is in the context of the EOSC AI Federation acts at this Federation Trust Hub. And in my role within the EOSC-related projects, I have been closely involved in onboarding of the first wave of nodes, and currently our team is supporting these nodes as they move into production environment of the Federation. And also we will support the second wave of nodes onboarding to the EOSC AI Federation. So practically speaking, once you're ready to connect your node AAI to my XSID, on the other side of the wire, you will most probably meet me and my teammates helping you through the process. So that's why I'm here today. So yeah, very nice to meet you all. Therefore, this part of our meeting, our training will be about what actually happens in practice when you are ready to connect your node AAI to the EOSC AI Federation. And there are 4 main steps. The first one is to understand the requirements of the EOSC AI architecture and implement your node AAI accordingly. The second one will be to connect and register your infrastructure service domain, your AAI, within my XSID acceptance environment. And during this step, you will register your client with my XSID and configure your site of integration. On the third step, you will need to validate the technical compliance of your implementation. This confirms that your AAI solution can perform remote token introspection according to ARC G052 and express group membership and role information according to the ARC G069. And finally, once we are confident that your implementation is technically compliant, you repeat the same integration procedure with the My XSID production environment. And the key point to remember is that connecting to acceptance environment validates your technical compliance. However, to connect to the production environment, it is also required to meet the necessary legal and policy requirement. And yeah, let's look at these steps in a little bit more detail. So first step is to build your AAI according to the EOSC AAI architecture. Congratulations, you're halfway there. The first half of the meeting was all about EOSC AAI architecture and how it works and looks like. So just to highlight again, please get familiar, read very attentively the EOSC AI Architecture 2025. It's all there. This document contains all the requirements for your nodes AAI, and yeah, take a close look at it. And let's move to step 2. So once you're ready to connect your node AAI to my access ID acceptance, you will find very useful document. It's referenced here on the slide, which is called Registering an EOSC Node Infrastructure Proxy with My Access ID. This document explains the complete registration and integration process. You will find all the screenshots and everything described step by step there. In short, let's move to the next slide. Yeah, thanks. In short, you will start by filling the service registration form for my Access ID acceptance. You will find link in the document. The form is very straightforward and it asks for information about your infrastructure proxy. A few important things to remember and to mention, please include the name of your EOSC node in the service name, in the registration form. This allows us to immediately understand the purpose of your request. So state as explicitly as you can that this is a request for the EOSC AI Federation. The typical grant types requested by a node infrastructure proxy are authorization, code flow, and refresh token. And once you complete the form, you select the grants, you will get client ID and client secret, and you will need to use these credentials to configure your node's infrastructure proxy. The important part that the same client credentials, the same client ID and client secret are also needed to configure client on your side that performs token introspections for tokens issued by other nodes. So you need to configure your client, your infrastructure service domain, and the client that will perform the remote token introspection. And also, we will need the following information from you: your introspection endpoint of your infrastructure proxy to be registered with my Access ID, and as it was mentioned by Mario, for ARC G069 compliance, you need a node-specific unique URN namespace. The easiest way to obtain the unique URN namespace is to register a namespace under the Jant URN namespace. Again, you will find a link in the reference document. Very straightforward process. You just need to send an email requesting the URN namespace, and basically the next day you will get it. And yeah, it will take you to the third step. Third step is technical validation. Once configuration and registration in the acceptance environment are completed, you will be able to run both test suites. Passing these tests confirms that your implementation is technically compliant. At the moment, both test suites are provided as Jupyter notebooks, so you simply install them, change a few variables, and you can run the tests. There are two notebooks. The first verifies the compliance with ARC G052 for the remote token introspection. There will be, you will find there two scenarios checked. The first one checks an access token issued by the tested node and introspected through my Access ID, which simulates peer node. And the second is the other way around. An access token is issued by my Access ID and is introspected to the tested node. And the second notebook verifies compliance with ARC G069, which defines how group membership and role information should be expressed. Basically, it follows the same scenarios as in the first notebook, but also validates syntax and semantics expressing the membership and roles. Every notebook generates the report. If you pass them successfully, you can just attach the results of your tests to the same ticket where we will be connecting to my Access ID. And yeah, that will be enough for us to see that all tests are passed or all good. Should you have any problems, do not hesitate to contact. We are happy to help you to go through the tests and to see how it should work correctly. And after all the technical validation done, has been completed successfully, you're ready to move to the production environment. And this final step includes legal and policy compliance. In practice, there are 4 main requirements. If you move, Mario, to the next slide, 4 main requirements. Your node must have a legal entity. You must have an acceptable use policy. You must have a privacy notice, and you must declare certified compliance, confirming that your organization will handle security incidents according to the certified framework. Once all these requirements are in place, you will complete the service registration form for production, which is practically identical to the one you did for acceptance. You will find the link in the document that was referenced on the step 2. And practically the same technical steps, but for your production environment. And that's it. From the moment that you submit your registration form for acceptance, you will be in contact and communication with our team. And if you have any prior questions, I think there will be our contacts on the last slide. But with this, that was it. Thank you very much.
Thank you very much, Irina. So now it's time for questions. We don't have currently any question on the chat, but I would like to, we are having one now. Let me check. So we have one from Esther. It's mainly a comment. I don't know, Esther, if you want to raise your question directly, if you have a question.
Yeah, it's okay. I thought to put it on the chat too.
Perhaps
Well, first, thank you.
Just a minute. Perhaps we could stop sharing.
Okay.
And yeah. Okay. Go ahead.
Thank you. Well, first, thank you for the training you're providing. It's quite good. I was just introducing a question out of context, but essentially my team is right now working on data spaces projects. They involve the decentralized identity based on verified credentials, UD wallets, and that stuff. So I was just wondering, what are your plans regarding when my Access ID will begin supporting this type of identity for the authentication between the nodes, or at least any updates on middleware to interoperate the EOS nodes with the data spaces?
Yep. So there are 2 elements here in this question. One is about, or 3, I would say. One is about verifiable credentials, wallets, data spaces, these 3 elements. We have actually discussed many of these things already within the EOSC working group. The main strong direction that we receive from all the EOSC nodes right now is stability and making sure that we deliver in a production EOSC federation. In this regard, at this point in time, the technologies like, as I mentioned, OpenID Federation, verifiable credentials, wallets, they are technologies that for sure in our roadmap we need to get there, but they are not there right now to deliver the production characteristics that we need. So at this point, in terms of the federation, we run also a survey across all the nodes and they categorize the requirements. The main message was the following: these things are very strategic, important directions. We need to enact on them, But right now, the focus should be production and making sure that we have the production capabilities of the federation. In this regard, I can say a few words about MyXAD. What we're working right now there is to support for verifiable credentials. This will be coming soon. And then to be able to start also working on some pilots with the wallets. We do understand that the ecosystem around wallets is still very fluid. So we do want to have this capability to start experimenting with the community, but by no means interfering with the production operation of the service. So this will be coming soon. Regarding the discussion about data spaces, what I can say is that there is already discussion with the data spaces about interoperability with the simple framework. There are discussions that are happening ongoing, many interactions, and it seems to be a very interesting place and discussions that are happening. Again, from what I see right now, we're discussing about some piloting activities. It is not a discussion about production or operations at this point in time. I hope that within the next months we'll have more information to share around this because there is an ongoing collaboration right now happening.
Okay, yeah, thank you very much. I understand.
Thank you, Christos. And we have another question in the chat, and also Alexandro is online. So if you want to raise your question directly, please go ahead.
Hi, can you hear me?
Yes.
Okay, fantastic. So guys, thanks. Really appreciated this presentation and also clarified some points. But I have two, let's say, questions and comment for you, and that I like to, let's say, treat separately. Let's start with the first. I'm just let's say hitting my head with for the let's say operation manager of the Italian node. And my first question is related to the real access to the resources by the people that are not from, as Mario said, the node X or node Y. So how we should, let's say, be in practice and practically try to, let's say, give access to the resources to these people by using attributes and groups, and where those attributes and groups have to be in some way, let's say, defined for that, because this is quite interesting. Because let's try, for example, let's keep Mario as an example. Mario is not belong to my Italian node, to the community of the Italian node, but he want as a node X access, for example, my, I don't know, quantum computer closer to the swimming pool. Right now I have no swimming pool and neither a quantum computer, but maybe in the future yes. And I have to let Mario enter in. But Mario is just one, is representing a community. So, and basically we have in some way to understand how to, let's say, properly use and propagate the attributes. This is my first question. And if you like to answer, I'm just stopping it before to go to the second.
Yes, I can say a few words around this because this is very interesting and very timely actually question, because right now in the EOSC working group we are working on the next update of the EOSC architecture, and the first point we're touching is exactly this with the question you asked right now. So let me give you some hints right now the direction we're going towards. First of all, we have to separate the authentication authorization infrastructure from the access policies, right? In order to determine whether a user should be able to access a given resource or not. This is a discussion about an access policy, and what the AAI is there to do is to facilitate these access policies. Just to give you an example, you may want to have users anonymously being able to access resources, no authentication is required. Or you may want to be able to authenticate users, but effectively there is no authorization required because the resources are public and you just want to track individual usage. Or you may have resources that are strictly controlled and you want to have only specific individuals that meet some characteristics being able to access. For example, in one of the nodes, in the EOSC node, the decision have been made by the owners of the node that only people who are in the universities, for example, staff or researchers should be able to get some kind of characteristics within that particular node. This access policy is really specific to the node. The node decides and the service decide what they want to enable. From the AI side, what we want to provide is the building blocks for all of you to be able to implement these policies. So to be able to authenticate users, identify them, and be sure that Christos is Christos and Mario is Mario and they are separate.
Yeah.
Then what is the affiliation of this person within their home organization in case you want to determine access policies based on that. And another pillar, which is also very important, is also whether a user is member of a given project that you recognize and you grant access to. So one of the important building blocks is this project kind of approach where we expect that for some closed resources, service operators, node operators will work in terms of project, somebody requesting access, being granted the project. Project means something that has a specific lifetime for a given purpose. And then from the AI side, we want to enable this exchange of projects, of project information across nodes. We have specific standards that we are already using, this ARC069, which express groups and project members information. These are coming, we can already find hints on this on the EOSC architecture today, but in the next version that will be published end of the year, we'll try to really elaborate on this and explain how nodes can utilize all of these things to enable this kind of access. Something also very important in terms of actually how EOSC is supposed to work. The entry point for users and services are supposed to be the nodes. So a user is coming from a node, is registered on a node, and then the question is how can propagate this information across nodes to enable and facilitate access. But the access policies should be and will be in control of the node operators and the service operators.
Sure. Yeah. Okay, but what I'm trying to think if maybe you answered on that if there is a way just to, let's say, share those information among the nodes in order that group A remains group A also in the rest of the community, don't speak about community, speak about federation.
Absolutely. This is the specification called ARC0069. I'm sorry for the technical language, but ARC069 is an ARC specification which gives us exactly what you described, how to express groups across nodes in this case in a way that are unique within the federation. And this is what we're already using. This is already described in the EOSC architecture today. And we're going to be providing more information about this in the next version of the architecture. So this is already covered. We already have the basis for this, and we're building on top of that.
Thank you, Christos.
Thank you.
And then I can pass to my second if there is no one
Please be brief.
in the queue.
We have
Okay, so
another.
OpenID Federation. We spoke even in other contexts, and Christos and Mario knows that. What I'm wondering here if what happened tomorrow, in the sense that today we understand that the technology that we implement with my SSID and all the things that came out with this presentation are, let's say, needed and are in production. But tomorrow, with the OpenID Federation, maybe we are going to, let's say, adopt it. Why? Because there are projects like EOSC Beyond and so forth, and other that, let's say, try to develop such information, such technology, such tool, and aspect. What happened tomorrow in the sense that how applying as we are now, the OpenID Federation will be, let's say, disruptive for us, and we have to make a lot of changes, or will be more easy for us to apply it and to bring it into production?
Alessandro, very good question. And the direction we're following in the EOSC working group is not to create disruptive changes. What will be happening is a transitional approach. And please do not expect any changes. When you say tomorrow is not tomorrow, really. Tomorrow
Okay, yes.
the next 5 years. So the model we're going to be following initially is establishing an OpenID Federation down the road between the proxies. So the services should not be affected, should not be aware at all, should not require this. The proxy of the nodes will still remain, at least this is the initial plan right now, and the OpenID Federation will facilitate the trust between the proxies. As tooling matures, and we're talking now about 5 to 10 years from now, as tooling matures and perhaps services may be able to have built-in support for OpenID Federation, we may be able to get rid of even the proxies. But this is a very big ask at the moment, right? We don't know where this will land. We don't even know if it's going to be successful to run the OpenID Federation at scale. Having said this, let me change my hat and say within the Xeant community and for Edugain, I hope that all of you know Edugain, we're already actually investing a lot on moving to production with OpenID Federation. This will give us a lot of experience, knowledge in operating a global interfederation using the OpenID Federation standard. And this experience, we want to bring this back to EOSC. But again, as I said, this will not be happening in the next week or the next months or even the next year. This is something that we have set forward for the future. What we want to do within the EOSC AI working group is to really start with piloting for those who can do that within the EOSC AI ecosystem, OpenID Federation in autumn. But this will not be mandatory. It will not be mandatory for anyone. Those who want to participate will be able to participate and start also building the future in addition to running a production infrastructure right now. But for us, the most important aspect is production use, being able to run a production service and making sure that each transition step is backwards compatible and doesn't require, as you said, breaking changes or big investments from the nodes. We need to go this gradually. So that's why I said we should always keep our eye to the vision where we would like to be, execute on small steps, and be ready to readjust based on the feedback information we receive from actually trying things out.
May I interrupt? Before we give the floor to Bo for the last question, I will share again my screen. And while we have the discussion on the last question, you will see the QR code for evaluating this session. We very much would appreciate your feedback on the session and on the online content we have or we will have. And you can actually use this link also to submit multiple questionnaires also for the previous sessions in case you didn't submit an evaluation questionnaire.
Just to finish, thank you, Christos, and really thanks to all the speakers.
So, Christos, in the meantime, you still have one question from in the chat, and I know Bo has raised his hand. So we have 2 minutes, more or less, or if you can give some feedback on his question.
I think the last question is about accounting, and on purpose we have called the working group Authentication Authorization Infrastructure Working Group, not accounting. Accounting, we consider this an orthogonal aspect. Having said this, the authentication authorization infrastructure, as it needs to support access management, it needs to support also accounting. What do you account on? So we expect to provide, and we do work with provide the building blocks, but accounting is not within the merit of the working group in the EOSC AI.
Okay, thank you very much.
Maybe we should give the floor to Bo because Bo asked about the
So
Edugain.
the question is
yes.
whether we can draw anything from the current experience of onboarding nodes for how much effort is actually required at the individual node for the AI integration.
This is a very good question, Bo, and I would say that it varies. So what we have seen in the last year with the first wave of nodes, and now we see also with the second, we have a variety of situations. We have nodes who are setting up now a new infrastructure from scratch, nothing there. There, of course, the difficulty lies in the experience of the people implementing the node. If they already have experience in setting up such infrastructures, I would say it is fairly simple to connect. We really have a very low-hanging fruit for what you need to do to connect to the EOSC AI. Of course, if you're not familiar with the ARC blueprint architecture and many of these things, some reading needs to happen, experimentation, and this is why we are here also to support you in this journey. The second type of nodes, though, are nodes that have already operational infrastructures. They have been operating, perhaps even in some cases, for decades, and they want to become part of the European Open Science Cloud Federation. How do they do this? Again, the technical aspects of connecting remain to be simple, but then you have to manage a really existing infrastructure and transition. We did exactly this this activity with one of the existing nodes, with the Panos node. The Panos node has been running an identity management service for the photon user community for more than 10 years now. And we had to connect the Panos node now to the EOSC AI. The connection was simple, but then the question is, what does happen with these tens of thousands of users that are existing users? So there we worked with them. It took around 6 months of coordination of how we can properly work with them and do a transition without affecting the end users and the services. This can be more painful, of course. So this requires more work and more thinking of how you do this, and this depends on each case, on each infrastructure. So this really varies, but I hope I did give you some insights on where we stand right now.
We thank you very much, Irina, Mario, and Christos, for being here with us today, and also all of you who joined this session. And please visit the academic website where you can find the presentation slides, but also many more things that will be uploaded in relation to this topic. And last but not least, please again, send us your feedback and any ideas or comments you have, both on the content that you would like to see from the academy, but also itself. So thank you very much for joining today, and see you next time.